So hello and welcome back everyone. In this video we are going to discuss the fourth problem of today's contest, which is maximum balanced subsequence sum. So let us see what the question is asking. So you are given an array and you have to pick some elements to form a subsequence. Suppose you have picked some elements like this 0, this 3 and 5. So you have picked indices 0, 3 and 5. Now what the question states that you have to pick such elements such that the adjacent difference between the elements which are picked, the this condition should be satisfied for every adjacent elements. So nums of j minus nums of I should be greater than or equal to j minus I. Or if we rearranged these elements, so we will get nums of j minus j should be greater than or equal to nums of I minus I. So if this is I and this is j, so let us write the nums of I minus I. So this is the value of nums of I minus I. So for each adjacent elements, this nums of j minus j should be greater than its previous nums of I minus I. So it has nums of j minus j equal to minus 2, which is less than nums of I. So it will be not a valid sequence. So a sequence to be valid, the nums of I minus I should have a non-decreasing value. So among all these subsequence which are valid, you have to return that particular sequence which has the maximum sum of elements, right? So let us see how we can solve this problem. So let us create a map where we have nums of I minus I as key and total sum it is having as value. I will tell you why I am creating this map, but let us have a glance what is happening. Now, this nums of I comma I denotes that what is the last element which has nums of I comma I and what the total sum it is having. So at first we are having nums of I comma I equal to 2 and total sum it can have equal to 2. It is the element sum it can have. Again, let us suppose we have some elements which has total sum equal to anything like 5. Then we have 4 and it has total sum equal to 3. And what we can do when we are at, we can iterate from start, and at each index we will find what are the valid nums of I comma I we can take. So we know what is nums of j comma j. So let us suppose we are having nums of j comma j equal to, we are having another number, let us say 6. Here we are having value equal to 4. Let us suppose we are having nums of j comma j equal to 5. Now we can take only those elements which has nums of j comma j less than or equal to 5. So we have stored all the numbers which we have iterated so far, and we will only take those numbers which are having nums of I comma I less than equal to 5. So these are the set of elements which are having nums of I minus I less than equal to 5. Now out of this we will choose the element which has maximum total sum, because it will we will attach this number nums of j to that particular total sum, because it will forming a valid sequence. So we will pick this total sum which is equal to 5, and we will be having another nums of I comma I which is equal to 5, and it will have a total sum now equal to, because earlier total sum was equal to 5, now we have added this nums of j to it, so total sum will be equal to 5 plus whatever is the nums of j. Suppose it was 3, so we have 8. So we have another nums of I comma I which is equal to 5, and it has total sum equal to 8. So in this algorithm, for every j you are finding what are the valid nums of I comma I you can have, and out of those valid nums of I comma I, you have to find which element is giving you the maximum total sum. And if you go on implementing this, it will lead you to TLE, because first you have to find what are the set of elements which are having nums of I comma I less than nums of j comma j. So for finding it, you can do it using upper bound. You can apply upper bound in this map. Suppose you apply upper bound on 5, so you will reach to this and you can go to the previous element, and you know that all the elements less than 4 will be having nums of I comma I less than equal to 5. But now when you know that what are the elements which are having nums of I comma I less than 5, now you have to iterate through all elements to find which is having the maximum total sum, right? So it will have a time complexity of n square. So let's see how we can optimize this algorithm. You can see one interesting thing here. When you have added these 4 and it is giving a total sum of 3, it is it really necessary to add this particular element? Because when you were adding this 6, it will say that, hey, what is the maximum total sum I can get which has nums of I comma I less than 6? So it will always return this particular total sum, or it will never be useful. So what you can do, you can erase it in the map. So when you are inserting any nums of I comma I, suppose you have inserted these 3 and which has total sum equal to 5, you can delete all the elements in the map which has total sum less than equal to it. So that is the particular main intuition. So this is the algorithm. So what you have to do, first you have to iterate from the start and go to the end. Now what are the possible elements in the map which are having nums of I comma I less than nums of j comma j? So let us suppose we have find this particular set which are having nums of I comma I less than nums of j comma j, and after that you will be having the last element as the maximum total sum. Why so? Because when we have added this 4, let us suppose we have a smaller total sum of 2, right? So when we have inserted this 4 comma 3, we have already deleted this 5 comma 2 because it has less total sum than it. So when we are having another query, when we have a total sum equal to, we have nums of j comma j, nums of j minus j equal to 5. So we will be applying a upper bound and finding the number which is just less than 5, and this will, the total sum associated with it will be the maximum total sum we can have. So this is the algorithm. I will show you the code. So see that I have initialized a count variable which will be storing the maximum total sum we can get, and I have created a map where the first value will denote what is the value of nums of I comma I, nums of I minus I, and long this value will denote what is the maximum total sum it can have. And I have initialized the answer to the minimum answer. This is no longer needed. Now for each index from 0 to n minus 1, I am first calculating which is the index which is having nums of I minus I. So we have a set. So this is the maximum element which is having nums of I comma I less than equal to nums of j comma j. After that, our current answer is equal to the maximum value in the array. And suppose we are at number, we are searching for number less than equal to 5. So after applying upper bound, it will be pointing to 6, but we want that nums of I comma I less than nums of j comma j. So we are decrementing the it iterator. After decrementing it, the current maximum value will be equal to nums of j nums of I plus the total sum it is having. Now we have to update the particular element maximum total sum it is having. So maximum total sum is nothing but the maximum total sum it is having initially or the current total sum it is having. Now this is the particular loop for erasing all the elements which has greater nums of I comma I nums of I minus I and less total sum than it, as we were doing here when we have inserted 4 and having total sum 3. We will be erasing this 5 comma 2 because it is no longer needed, because we will be always returning this total sum. Okay, so this is the particular equation for erasing all the elements which are having less total sum, and we will update our answer which will be maximum of current answer or the previous answer, and we will return the answer. So this is the accepted solution. Yeah, so this was the explanation to the problem. If you have any doubt, you can ask me in the comment section. I will try to answer as quick as possible. Thank you so much.